Oh, hi. It's another banner day for space weather. There is another coronal mass ejection headed our way. One may have already struck and been a complete dud. There should be a high-speed coronal hole wind stream as well. We're expecting another CME impact on the 10th of May. Yeah, May 10th. It just happened early this morning. We'll talk about that and a lot more on today's Daily Space Weather. Thanks for tuning into the Smash News Network, least busted name in news. I'm your host, Dan, a.k.a. Smash-O-Mash. This is a 24-hour video from the SDO. So, let's take a look at the coronal mass ejection here. It came from this area right here. Here's a close-up. And you might not be able to see ejecta coming out there, as there is very little contrast for an instrument pointed directly at the solar disk. So you might not see it coming out. It did come out. We'll get to it later in the video and show you some detailed coronagraphs and analysis. We've also got some massive filaments, like this one up here around the North Heliographic Pole. Also a North Pole-oriented coronal hole up there. Another indication that we are not yet at solar maximum. Here's the southern hemisphere. Again, some large plasma filaments around there that you can certainly see well on this imagery. And again, CME coming out of that middle region there. And here is the sunspot scenario for the past, well, that's yesterday plus today. And there is a large active region, probably a large sunspot group rising in the east. We'll get to that later in the video. First, the colorized magnetogram. Basically, solar activity has been stable since yesterday. And let's briefly take a moment to take a look at what's going on around planet Earth. Starting out with volcanoes. We're always interested in the volcano rundown. So here it comes. First on the list is Sakurajima. Sakurajima is producing a 7,000-foot plume of volcanic ash over the Isle of Kyushu, Japan. Suwanosejima also producing an unknown volcanic ash cloud. Please do not pole vault the caldera. Semeru also exploding. Over East Java, we see a 14,000-foot plume of volcanic ash, flight level 140. Dakono, flight level 070 over Dakono. Popocatépetl exploding, flight level 200 over central Mexico. It's a 20,000-foot ash plume, 23,000-foot ash plume over Colombia from Nevado de Ruiz's explosive activity. Revenador, sporadic emissions there, as Revenador also explodes. No indication on the ash plume size, but in Ecuador, Cotopaxi is erupting. Also in an explosive fashion, 22,000-foot ash plume, flight level 220 over Ecuador from Cotopaxi, and Sabancaya unable to detect. Let's move on to seismicity. There is a 90-day graph, and it has been mild in terms of earthquakes for the past 24 hours. No major quakes, and only a couple that are over a 5 magnitude, like this 5.2 at the Philippines. That one is expected to have done some damage there, close to Luzon, apparently, or the Isle of Luzon. And just scrolling up the list here, we will cite quakes over a 5 magnitude. And again, not many of those. There was a 5.0 south of Fiji. And that one was at extreme depth, nearly 550 kilometers estimated depth. Also, Ecuador had a 5.2. That was at 0 dark 51 just this morning. Besides that, as far as 5+ magnitude quakes, largest quake of the past 24 was a 5.8, very far south in the Pacific Ocean there, near the Pacific Antarctican plate boundary. 5.8 occurred at 6:02 this morning, a 5.8 there in the Southern Ocean. And let's get back to space. Here's the past 24 hours in the ever-popular house favorite wavelength, 171 angstroms. It's great at showing the lower corona. You can see the way those iron atoms are orienting themselves to the magnetic fields. That's why it looks like magnetic field force lines. It's because that particular species of ionized iron orients to those magnetic field lines. Anyway, that's what's going on in 171 angstroms. The 10.7 centimeter radial flux has now dropped below 155. Or is it 157? I think it's at 157. The 10.7 is at 157. Yeah, there we go. The Space Weather Enthusiast dashboard. That is a one-year graph. To put that in context for you, the black line is the radial flux, and the red line is the sunspot number. Again, we are seeing significant resistance around 155 solar flux units. So that seems to be some sort of a support level for the radial flux activity. And as you can see on the Space Weather Enthusiast dashboard, NOAA is forecasting extended periods of geomagnetic unrest into tomorrow. So we could see some aurora at mid-latitudes tonight. I find it kind of unlikely here, as I would tend to agree with NOAA that the likelihood of major geomagnetic impacts have significantly dropped, as those coronal mass ejections that we forecasted there, they should have already showed up. So now keep in mind they can be affected by coronal hole high-speed streams or even each other. But so far it's been a dud. We haven't seen any kind of a KP 7.3 as forecast. But there is still some possibility of seeing the aurora tonight, the night of May 8th into May 9th. Also, we are expecting another CME impact sometime, I would say around probably midday or later on May 10th. There will be additional models coming out later today about that. Here is the NOAA model, the current NOAA model, which isn't modeling that most recent CME. So far it's been pretty much a non-story as far as major geomagnetic impacts. We saw a stronger impact from a coronal hole high-speed stream than we saw from any CME impacts. It was accompanied at the leading edge by a strong magnetic field, and in fact that could have been the coronal mass ejection showing up earlier than expected and mixing in with the leading edge of the coronal hole high-speed stream. That could be one of the things that occurred there. It could have amplified that coronal hole high-speed stream. This is NASA's forecast, also not modeled here yet, the new CME. It is not perfectly earthly directed, but it should include a significant contribution to the Earth geomagnetic system. So here's the past 4 hours of Earth's magnetic moment from space, our Geospace Magnetosphere movie. And yeah, things have been calm. So only brief perturbations to the magnetic fields and so forth from that incoming solar plasma. There you can see some variations likely happening in the past 4 hours, the time frame depicted there. Here are the past 4 hours of Earth's magnetic moment from the ground. Not super exciting, but you're better off over forecasting these sorts of things. Keep in mind some people need to get in radiation-proof rooms, like astronauts. We've got a cosmic ray report coming today as well, so hold on to your hat. Some interesting stats coming out. So we've been streaming the geoelectric field for the US and Canada. This also helps to show people the likely spots to see the aurora. And again, not too likely at mid-latitudes. We are located right about here in Lehigh Valley, Pennsylvania, right about there where the pointer is. And I don't suspect any aurora were visible in Lehigh Valley in the past 24 hours. So we did see a KP 4.67, a geomagnetic unrest period there, almost what you'd call a geomagnetic storm, a KP 5 or G1 class geomagnetic storm. Current conditions are KP 2. It is calm condition at the moment. So there are some indications that we did see some minor CME impacts. Like right here, we saw the magnetic field shift right about when we expected these to arrive. So right in that moment there, you can see the field came up. The solar wind density dropped down, actually. And you can see a little change in the plasma temperature, which is this bottom pane. Those are all indications that there was a very minor, weak, glancing blow type coronal mass ejection. Also keep in mind there are coronal hole wind streams out there, so we could see a mixing together of multiple phenomenon here. I'll just report the current stats, which are just over 500 kilometers per second for the solar wind speed. Solar wind density here just under 10 protons per cubic centimeter. Keep in mind, folks, that those are measured outside of Earth's magnetosphere out here at L1, Lagrangian point 1, the gravitational equilibrium point where the sun and Earth's gravity are equal. You can have a spacecraft orbiting that location, and that is where the solar wind is measured. Next are GOES magnetometers here, and you can see some spiky readings there. That is typical of the arrival of additional solar plasma. Let's take a look at the heliospheric current sheet. Earth is pretty much right in the middle of the north magnetic pole. So here you can see the North Pole oriented plasma sheet there depicted in green, South Pole plasma sheet depicted in red. I would also note there is a massive amount of coronal hole at the North Polar region. You see that huge green blob there? That is a very large coronal hole located at the heliographic North Pole. So, that's very interesting, as that has still not left the North Pole, which means you still can't declare solar maximum if you'd like to be accurate. So here's our line of sight field plot depicting the gong magnetogram in gray, black, and white, the solar B field in blue, solar polar fields in red for south on the opposite side of the sun, and north for green on this side of the sun. That brings us to coronal holes. Super important in the solar cycle process, as coronal holes show us the solar magnetic field reversal process happening. All the coronal holes on the Earth-facing portion of the solar disk are North Pole oriented. So there's the final frame. And here is 211 angstroms from SDO for the past 24 hours. Again, those are all North Pole oriented coronal holes. So from these all the way down here to these over here, these North Pole, North Pole, North Pole. And that brings us to sunspots. Current situation is no new sunspots are getting named. You may see this active region right here. That's just a plage at the moment. At least when we did show prep, that was not a sunspot. I don't see any likely new sunspot groups to get named here. Looks like 3299 is already named. So the next sunspot will be number 3300, by the way. And let's take a look at sunspots here. And we'll show cosmic rays next. So there is the SDO intensitygram, or SDO continuum. Let's zoom in a little bit closer here. And those groups have been largely stable. We'll also switch to the spectacular 1600 plus 1700 angstroms. By the way, there was also a solar energetic particle event and a long-duration M-class flare. We'll get to it next, as we are about to move to cosmic rays. So we're starting out as far south as we can get at DOMC Antarctica, and we saw a little 4-bush minimum happening here. That happens when we see cosmic ray flux significantly increased, correlating with incoming large amounts of solar plasma. So this one back here, this was the major geomagnetic storm that we had, the largest one in over 20 years. We just recently had another smaller 4-bush maximum there. I mean, 4-bush minimum, I should say. That little dip there, an indication that a bunch of plasma showed up. So anyway, that's DOMC Antarctica showing a significant downtick over the past 30 days of cosmic ray flux. DOMB Antarctica also showing a significant downtick over the past 30 days, headed way up north to Finland. There's Oulu, Finland, also showing that 4-bush minimum. And then a signal emerging down there at the bottom. So it looks like we're seeing a dip in cosmic ray flux. Now, if you're not familiar with cosmic rays are energetic particles similar to the solar wind in their chemical componentry, meaning they are mostly hydrogen nuclei. There is also, that's about 90% hydrogen nuclei, and then something like the other about 10% is mostly electrons and helium ions, and then there's a tiny bit in that 10% that is heavier elements that we refer to as metals in cosmology. And cosmic rays are primarily coming from outside the solar system. We see a big decrease in those when we see major geomagnetic events on planet Earth. So let's also look at Mexico City. There's Mexico City also showing that 4-bush minimum and a major significant decrease in cosmic ray flux over the past 30 days. We'll also look at Athens, Greece, which has a big chunk of missing data but still does show that 4-bush minimum. Also a significant downtick over the past 30 days. Last but not least, Apatity and Barentsburg, both showing similar graphs. Significant downticks over the past 30 days of cosmic ray flux. So for all of you out there who are hoping that the world will end, if you think cosmic ray flux is going to be the mechanism that causes the world to end, sorry, there's a big decrease in cosmic ray flux, as we would expect with such a strong solar cycle. Also, solar energetic particle events are likely to reduce cosmic ray flux, as you've got a bunch of particles circling the North Polar region at the moment. So that was caused by a long-duration solar flare, the M-class flare that sparked the next coronal mass ejection likely to strike Earth on May 10th. The GOES proton flux there just about to reach warning levels, and we have been seeing some polar radio blackouts. Now, if you want to follow the radio blackouts yourself that are induced by solar flares around the equator and solar energetic particle events around the poles, follow the D-absorption region predictions. The D-region absorption predictions. There you can see those solar energetic particles starting to show up at the poles, and we're not sure where the top will be of this solar energetic particle event. It looks like it's actually calmed down there. That doesn't really make any sense. There we go. That's the current situation. So you can see the radio blackouts are getting significant enough to spread to the southern polar region here, despite it being autumn down there. So this could be a significant energetic particle event. We'll be keeping an eye on that. And when I say ion, well, pardon the pun. Those relativistic protons, they get stuck on Earth's magnetic field force lines, and their deceleration creates radiation, and that creates attenuation of the D region of the ionosphere. So here's that long duration flare. The peak flux was around 2320 universal time. And that flare lasted, well, it started out about 7:30 universal time, and it didn't really end until about 4:30 this morning. So a very long duration flare there. And let's take a look at that M-class flare coming from this sunspot group in the north. Here's another 24-hour video. We'll zoom in a little bit closer on that for you. It's our 94 angstroms SDO wavelength. One of the many species of ionized iron covered by the SDO. It's part of the ultraviolet, the EUV, or extreme ultraviolet spectrum. It is a higher frequency light than is visible to the naked eye. It's also not visible from the ground level. You got to be in space, as those wavelengths are filtered out by the Earth's mesosphere, I believe. Stratosphere? Mesosphere, I want to say. Anyway, this brings us to our next section, which is, hey, you're all encouraged to look up. This is what's going on over Lehigh Valley. We like to orient our viewers before we start to talk about things like coronal mass ejections. This is what's going on over Lehigh Valley, Pennsylvania at the moment. You've got the Summer Triangle up there, which consists of Deneb, Vega, and Altair. And if you're up before dawn, you might see Jupiter and Mercury being chased by the sun. If you're up after dusk, you might see Venus, which is less than a week from reaching its highest point in the sky. Venus, the third brightest object visible from Earth. Here's your solar system forecast. We've got a gibbous waning moon at the moment. Here's where things will be in a week. We'll have a crescent waning moon by the 15th. And here come some coronagraphs. So there you can see that halo-like eruption right at the beginning of the day today, associated with that M-class flare. I would also note that there is a huge active region, or maybe even two huge active regions, rising in the east. You can see a lot of plasma suspended out there. There is nothing to blame for that besides magnetic fields. And there's nothing to blame for that besides sunspots or large active regions. So that's one of the reasons why we show the 193 angstroms wavelength on the coronagraphs. Because of that, that is an unsustainably huge plasma filament. Anyway, there you can see those, at least one CME propagating there. And here is just the 193 angstroms wavelength by itself. Now, if you haven't checked out the products featured below the video, check out the description. We've got all kinds of ways to not only help out our viewers, but help this channel continue to exist. So if you enjoy the content, please click the things in the description, one of which would be our Redbubble shop. Today's featured product is MAXA, which stands for Make Astrology and Cosmology Science Again. Now, of course, there are plenty of real science people in the realm of astronomy and cosmology, and there are plenty of utter hack frauds doing pseudoscience who will tell you things like everything's connected and the universe is electric, which is just ridiculous. These are people who want to have a generalized pile of nonsense to explain their universe. And it's a little bit more nuanced than everything is electric and everything is connected. So, lots of issues with the realm of cosmology, and part of the reason why we have this channel in the first place, we are advancing heliophysics in order to advance cosmology. So, I don't believe that we understand what stars are made of, at least not generally speaking. Most astronomers think stars are made of balls of gaseous plasma, and there are a lot of observations to suggest otherwise, and the implications on cosmology are significant. So I almost became a cosmologist in the mid-90s. I almost majored in that. It would have required me to move to California or create my own major, and I said, there's no way I'm doing that. So I decided to become a pro cyclist instead, and let's move to our coronagraphs. So here is yesterday's coronagraph imagery, and you'll see right at the end there, the final frames, you'll see that halo eruption, and then in the beginning frames of today's imagery, you'll see the rest of that halo eruption. Again, we are expecting impact from that around something like midday or later on the 10th, I would say. Here's Soho Lasco C2 and C3. And we've got some custom videos of that as well. We'll also show Stereo A. Stereo A located here just a few degrees behind Earth, orbitally speaking. And we've paused this here at 2353 for stereo. Excuse me, 2353 for stereo A, and 130 this morning for the Soho Lasco C3. There you can see that halo coming out. Stereo A features a couple hours of missing data there, not optimal. Looks like there may be two separate events happening there. That one looks like a smoke ring. At 253. So that part is definitely off to the southwest. But again, there does appear to be an earthly directed component there. And let's move on to talk filaments. So we showed you some huge filaments at the beginning of the video, and here are some more. Like you can see this huge crown filament up here, crown prominence up here. More filaments rising here in the east. So those do have the propensity to occasionally eject. Sometimes they collapse too, folks, but sometimes they eject. So we show it daily on the channel. And you can name them after living people if you like. Follow the hashtag #NameThatFilament over on Twitter. Hashtag #NameThatFilament if you want to name filaments after living humans. So here are the past couple of hours from the GOES 16 SUVI. We're going to come back to that in a minute. First, SDO 211 plus 171 angstroms wavelengths. That is the past 24. And there's a great close-up of that most recent activity headed right toward your doorstep. Again, here is the past couple of hours, and we have another CME propagating as we stream the video. So you can see this huge prominence happening down here. Some of that ejecta is likely to end up in the greater solar system. Also, another CME from up here looks like it is occurring. So certainly no slouch. Plenty of activity here, despite not that many sunspots and not that high of a radial flux number. A prime example of how, well, I mean, we've said it a million times on the channel. You don't need sunspots, and you don't even need to see solar flares to see coronal mass ejections. These are separate phenomenon, folks. Solar flares are X-rays. Coronal mass ejections are diffuse gas. And let's get back to it, because it's time for bonus features. Starting out with Satellites Community Dashboard, looking for charging hazards, and we've got only some minor ones at the moment. Those are located in the Eastern Pacific. Those minor charging hazards caused by low-energy electrons on the outside of spacecraft shouldn't cause any major communications errors there. Here is this GOES electron flux, which has dipped precipitously as we forecasted on the channel. Yeah, we forecast the electron flux occasionally. And there is the NOAA forecast model. You can see, if you watched yesterday's video, you would know how accurate our forecast was. A little bit more accurate than NOAA's, I think, in this case. See yesterday's daily space weather video. By the way, if you weren't aware, we've been putting these videos out for pushing 6 years. I think in the month of June we'll be at 6 years. And thanks for leaving a comment, TinMan1057. So that's your relativistic electrons forecast model. Here is the one-year graph to put it in context, following the largest trough and longest peak, actually, at least at very high levels of electron flux for the past year. That's from Solon.info. And we'll also show the vibrational frequency of the F layer of the ionosphere, located at 300 kilometers of altitude, not to be confused with the D layer, which we showed earlier. That's the layer that gets attenuated by solar flares, or at the polar regions, attenuated by solar energetic particle events. The D layer. Yeah, that's the mesosphere. The thermosphere starts at the E layer and so on. And yeah, here is the vibrational frequency going on. This depicts megahertz, millions of vibrations per second. There are some low frequency anomalies certainly in there. More low frequency than high frequency for sure. Here's the anomalygram depicting anomaly in megahertz from a 30-day median. Now you may be looking at this area right here. That's the South Atlantic anomaly. That is where you see variations happening constantly. It's the weakest part of Earth's magnetic field. There is also an area over here. I believe it's around the African equatorial coast on the west. Looks like it indeed is the second weakest part of the magnetic field. And those two spots have been pretty stable here for the past several months. And keep in mind, when you see lots of low frequency anomalies, it is typically, I would guess that it is that the ionosphere is puffing up. So this most recent bit of activity here has been a lot more minor than the last major geomagnetic storm. Let's show the latest images. Move on. We've still got meteorology to cover here. So here is the ionogram at 11:30, and there is the anomalygram at 11:30. We'll also show the total electron content, the free electrons to your GPS satellite to your handset, as space weather affects your GPS accuracy. And at the moment, well, there are some anomalies happening there in the total electron content. We'll let that play through a second time, and then we'll show you just the North American total electron content. Electrons getting a little bit jiggy here. Again, this is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. It's the free electrons from ground level to your GPS satellite, which is in the inner portion of the outer Van Allen belt at about 12,500 miles. And here is your North American anomaly from the 10-day average. So this may have some predictive value. We do show this data when it is available. It isn't always available, but when it is, we will continue to try to show it. That's your total electron content anomaly from the 10-day average. Last but not least, we've got the latest high-res imagery. There is the SDO magnetogram and intensitygram. When we did show prep, that was not a sunspot, and that is still not a sunspot. Here's your full disk rockback, as otherwise sunspot activity has been stable. That brings us to our meteorology segment. We'll start out by looking at nullschool.net's space layer. So there's the space layer, and the likelihood of seeing the aurora at the moment is quite low. And let's go to meteorology as we bridge the gap between Earth weather and space weather. Like sands through the hourglass of time, these are the surface winds of your lives. These are the jet streams of this third of the planet. The central world's jet streams are looking like this. And the surface winds are depicted here. Surface winds of the Americas shown here. And the jet streams right there. Moving on to see the sunrise and actually see the sunset. And also, you can see those solar rays getting more direct as summer approaches. for the North Pole. There's a lot of snow to melt, so be ready, as snowmelt is expected to continue to cause significant flooding here. And snow even continues to fall in some locations. This is the visible satellite, by the way. And you can share this NASA Goes Interactive Weather satellite imagery to all of your friends and foes on the internet who say herp derp. The planet is not shaped like an oblate spheroid. It's shaped like a croissant. Herp derp. The galaxy is going to kill you. Herp derp. Planes are spraying chemicals. Herp derp. Contrails are geoengineering, etc. Here's your weather.gov map. If your location is lit, head to weather.gov and click your location. Not that many weather warnings there. A bunch of... Gonna stay calm. There is the key to show what those colors mean. Again, weather.gov. If your location is lit, click your location on weather.gov. And here comes some forecasts. This is the GFS 72-hour pressure and precipitation forecast. As again, snow continues to fall in parts of the Rockies and the northwestern U.S. And since there's going to be a lot of melting happening, let's show temperature anomaly. There's the temperature anomaly forecast in degrees Celsius, based on the same model, the GFS 72-hour. We've got some anomalously warm temperatures in Pennsylvania the past couple of days. Next, your lightning mapper. Quite a bit of lightning here across the U.S., especially in the central part of the country. And that animation looks like crap, and it is pissing me off, so let's just go to a real-time map instead. Here's lightningmaps.org. And we do indeed have some active cells here north of Nashville, also east of St. Louis. Those are pretty minor thunder showers. Next time you hear thunder, check out lightningmaps.org, powered by blitzertung.org. And if you want to learn the best language to say curse words in, learn German. Even non-curse words sound like you're angry. Ich möchte ein Franziskaner. That means I would like a Franziskaner, which is a Hefeweiss out of Munich. Yeah, Munich. Now, if you are into supporting the channel, or perhaps supporting your own health, you may see that this channel does feature a paid promotion. That is our Hemp Lucid link. So consider supporting the channel by picking up some Hemp Lucid products. If you already shop there, enter the promo code SMASHAMASH to save some dough or use our link. You'll find the link below the video in the description, as well as on the homepage at smashamash.com. Welcome to the Neo Renaissance. Congratulations on realizing the channel exists, and thanks to Hemp Lucid. You are helping to continue the possibility these videos will continue to exist, remain publicly visible, and free for all to view. So again, use our link or the promo code SMASHOMASH for your Hemp Lucid purchases. Link below the video and on the homepage, smashomash.com. You can also find links to the coffee that I'd be drinking, had I remembered to actually get my coffee today. It's Cameron Scandinavian, so save some money on bulk spices. Learn something about the supplements that I take. Some of them are actually shown here on the Amazon shop. So you can find the link to that below the video as well, also on the homepage at smashomash.com. Also, thanks to the Smash team. There's the homepage, smashomash.com. Follow us on Instagram if you're interested in things like health, fitness, diet, and lifestyle stuff. We put up posts regularly, most days on Instagram. All the links to most of the content there located right there on the homepage. Welcome to the Neo Renaissance. And these videos are brought to you in part by the contributions of the Smash team at smashomash.com/Smash team. So the best way to support the channel is to become a member of the Smash team. It gives us some idea of if there will be any income as a result of the channel. Sign up for a gold or silver monthly membership, or the best value is a gold annual paid-up subscription. It's almost like getting 4 months of our additional content for free. because there is complimentary merch. Smashomash.com/Smash Team. Again, it's the subscription services location. We launched it back in October of 2021. It's superior to Patreon. Now we're looking at the precipitation type, since we do have some mixed precipitation falling in some areas here, like Northern California, parts of Oregon, Montana, Nevada. Seeing something besides rain coming down. One of the many great features of Windy.com is the precipitation type map. Windy.com, free mobile app. Check it out if you haven't. Here is your U.S. Doppler radar map. There's the full 50-state view. Here's a lower 48 view. And bear with us a quick moment here while we bring up some additional data for you. Sometimes you run into the problem where things refresh because of the length of your video, for example, and you just have to call an audible, perhaps like Peyton Manning. So here's what's going on in terms of clouds and fog. Here is the water vapor map. See some rapid cloud nucleation and then some heavy rains here in the east coast of Mexico. And some large pressure gradients forming here as a result of multiple different interactions here. You've got some moist air. You've got some dry massive air, which is effectively a high pressure system. And here's your recap. U.S. Doppler radar. Indianapolis, you're in the crosshairs for the next few hours. There is the clouds and fog scenario, 3.9 micrometer radiation map. And that's the water vapor. That should create some decisiveness if your Doppler is unclear. Everything should be moving in a pretty predictable fashion, though, today, based on what we're seeing in the lower 48. Thanks for tuning in, by the way, to the Smash News Network, least busted name of news. Once again, congratulations on realizing the channel exists. We'll be keeping you posted on what's going on in space, Earth, and beyond. So anyway, we'll see you soon. I've been your host, Dan, a.k.a. Smashomash, signing off. And may that solar wind be at your back.